Hi, my name is Premishwar. I'm 16 years old and I'm from SMK Kota Komuni.
Hi, I'm Aishwarya Devi. I'm 13 years old and I am from SMK Kota Community.
Hi guys, my name is Pranavish. I'm from SMK USC 12 and I'm 16 years old.
Hi, my name is Kubineswaran. I'm 15 years old. I'm from SMK Tinggi Kaja.
Hi, my name is Diveshwar. I'm from SMK Kota Komuni and I'm 17 years old.
And we are pioneers.
Landfills are a serious problem around the world. According to the World Bank, global waste is expected to grow to 3.4 billion tons by 2050. This problem is caused by waste management in most countries. Around 44% of these landfills are food wastes and other biodegradable goods. These wastes are left to rot in landfills and release huge amounts of methane and carbon dioxide gas, which can contribute to the greenhouse effect. The two main Sustainable Development Goals, or SDGs, addressing this problem are SDG 12 of Responsible Consumption and Production, which addresses the poor waste management, and SDG 13 of Climate Action.
But how can you solve all these problems?
Well, vermicomposting is an effective way to solve this problem. Vermicomposting uses worms to convert organic materials such as food waste into nutritional fertilizers known as vermicompost. This process involves two different scientific principles. One of them being the nutrition cycle, which is a system where energy and matter are transferred between living organisms and non-living parts of the environment. For instance, the sun provides nutrition to the plants, which are then eaten by animals, which are then eaten by humans, who also eat the plants to gain nutrition. As for the leftovers, they usually end up in landfills, disrupting the natural nutrition cycle. But with vermicomposting, this problem can be averted. That brings us to our second scientific principle, the use of decomposition. Instead of going to the landfills, the leftovers will be fed to the worms instead. The worms will then help break down the dead tissues of the waste and convert them into fertilizer that provides the nutrition back to the plants. That's all great, but how can this help in reducing landfills?
Well, we should focus on preventing food waste from ending up in landfills. To do this, we need to promote vermicomposting, especially in urban areas. Vermicomposting is currently done by feeding waste to composting worms in a bin producing fertilizers. Although useful, there are many challenges if conditions in the bin are not suitable, like worms escaping the bin or dying, bad quality fertilizer being produced, and the worm bin being too wet or smelling bad. This is where our invention comes in, Worm Patrol.
Worm Patrol is an automated worm bin aimed to stimulate the natural living condition for worms in houses using IoT technology. It allows the user to monitor the condition of their worm bin, and it also provides alerts based on collected data for maintenance.
But how does it work?
Well, Worm Patrol consists of two bins. The upper bin, which houses the worms, as well as the cooling fan, temperature and humidity sensor, and soil moisture sensor. Whereas the lower bin collects the excess water and houses the weight sensor and water sensor. There are four main types of worms used in vermicomposting. We are using the African night crawlers, which are also known as Eugelius eugeni. All our sensors in our invention are connected to an Arduino Nano, which is responsible for deciding whether to turn the fans on or off, to disperse heat, and also to send sensor data to the Raspberry Pi. The Raspberry Pi will then upload that data to a Firebase real-time database, and as this is happening, there will also be a Firebase stream handler, which will send the notifications to the user if there are any abnormal readings via the Worm Patrol app.
Wait, there's an app? Yeah, the app itself uses the user's email and pairs it with the worm bin for authentication. It provides the real-time data, which is updated every 1 hour, as the changes in the worm bin are minimal but can accumulate over time. All the data stored in the database will also be available in the app in a graph form. The app also comes with a community feature which allows users to share their experiences and also ask advice from other users. There's also a tips page that can guide users into the world of vermicomposting.
Surely, someone else has thought about this before, right?
Definitely, but automated worm bins are only used in big industries. Our invention, Worm Patrol, is original because it comes with automation at an affordable price. Our invention also includes an app with a built-in community feature and tips to get users started. When we present the solution to communities, we can help reduce the amount of food waste that is being dumped in landfills.
What is it made out of and how much does it cost?
The materials we use for this invention is durable plastic for the box in order to withstand the weight of the vermicompost. The cost of the whole invention is 401 ringgit, including the Raspberry Pi, Arduino, sensor, and other accessories such as the legs and electronics casing. Although, during the development of the project, we realized that we can easily replace the Raspberry Pi with an ESP8266 Wi-Fi module, bringing our cost down to 275 ringgit.
In the future, we plan to make Worm Patrol even more compact and cost-friendly. We hope that Worm Patrol can make a big positive impact to our environment and make the world a better place to live.